The term sigma, it has been taken from the Greek alphabet. It uses, or it is, used to define the distribution or the spread around a mean. There is always in mathematics, we read that there is always a mean around which there is a spread, or there is, the process is spread, or the size of the, within the specification limit, there's always a mean. Around the mean, on the plus side, on the minus side, we have the different, the spread of the process. So in this context of business or the manufacturing process, sigma, we can call it as the capability of a metric, which indicates how the process is behaving around a mean value. We set the mean value, we have the specification limits. So we would observe how our process, behaves within those specification limits around that mean value. So that is, how we study the Six Sigma. This is, sigma is standard deviation. It's a measure of variation around the average. The black spot shows the average. Around this, the other, the sample averages are spread. Or the sigma level, this is sigma. What is sigma level? Sigma level is normally the half of the number of standard deviations. And these standard deviations are the ones which are fitting within the, specification limits. There is one lower specification limit, there is one higher specification limits. So in the first, we can see that like 8 sigma levels are there. So sigma level would be 8 divided by 2, this 4 sigma. Then similarly in the bottom level, we have reached the 6 sigma. So sigma level is always, it can also be said that as it's the measure of the number of defects per opportunity produced by a process. This is, the beauty of the process sigma. Sigma, people say that we will call the defects as, opportunity to improve. So they also call it as a defects per opportunity. This is, I was talking about the mean. We have the upper specification limit. We can see that this is the inflection point. There's 1 sigma. If we just extend it, we can see that there are 3 sigma limits up to the upper standard limit, upper specification limit. The size of the standard deviation shows that distance between the inflection point and the mean, that is, what we call as a sigma. So we can say that process has, it shows 3 sigma capabilities. That is, the 3 variations or deviations, they are fittable within the upper limit, these 2 limits, the mean and the upper specification. We can see that, yes, these 2 processes, the above one shows plus minus 6 sigma capability, and the lower is the 3 sigma capability. As variation decreases, the probability of a defect decreases for a given specification limit, and we can say the capability has improved. So in the above, as the variation decreases, we can see that 6 variations, they are fittable up to the upper specification limit, and whereas the bottom shows the spread is more, the variations that are fitting is only the 3. So we have reached 3 sigma limit. Lesser is the standard deviation. We start from the top, the highest one. It has the minimum standard deviation. More precise or consistent is the problem. So the central one is the most consistent as compared to the one having the most outer limits. So process capability is a very important term in Six Sigma. Process capability shows that how a process is, running to its specification limits, how the variation is running. Larger is the index, larger is the specification limit, less likely is that the process would, or a product will fall outside the specification limit, and less would be the wastage. I would explain it with a very good example. yes, we can see here is that you can take an example of a car and a garage. There is a garage. The size of the garage door is, we can say almost equal to the width of the car. So when you want to park your car in the garage, can you imagine how would we do it? If the size of the car is more, naturally we are going to crash against the door of the garage. If it is just equal to it, so very efficiently, what we can do is we can just fit in the car within the garage. So we can say if the car is only a little bit smaller than the garage, you will better park it outside the middle of the garage. If the car is wider than the garage, it doesn't matter if even it is centered or not, it will not fit, it will crash. So what I want to say is that it will fit and you have a plenty of room if the variation or the limits are greater, if the size of the garage is more. So if you have a process that is in control and there is minimum variation, you should be able to park the car easily within the garage. So that is garage width, size of the garage, it corresponds to the specification limits or, the limits which meet our specific customer requirements. So, and car, shows your manufacturing. It fits it within that. So that means you have a good fitability with your specification limits. So when you say capability is half, that means, your car is wider than the garage size, you would definitely crash. Capability is 1, that means size is almost equal to the size of the car is equal to the garage size. That means you are just touching the nearest edge. Capability is 2, that means your specification limits are almost 2 times. So that means your width, you still have a flexibility to grow 2 times before touching. And similarly, 3, you can grow 3 times before touching. So that is, how we capabilities. This is a very good example of showing why Six Sigma is limit, very important. All of you have been to the pizza store. You go to a Domino's and what do we expect at the Domino's? Quality of the pizza, say it is guaranteed. Domino's is expected to give us a very good quality. The next comes is that we want delivery to be fast. Even, the Zomato or the other, these apps, we expect these Zomato also to deliver us fast. So the fast delivery is one of the most important expectations by the customers. And Domino's, it says we guarantee that waiting time would be 30 minutes or less. Just looking at this line, 30 minutes or less, it looks that, oh, they are doing wonderfully well. It's a process well within control. Hardly, maximum you have to wait for 30 minutes. And, say there were about 200 deliveries in a day. And end of the day, if we measure the performance and total of the delivery time and divide by 200 deliveries, and the average delivery time would come to be 23.5 minutes. Guarantee was 30 minutes or less. And average delivery time is, 23.5 minutes. A layman would say, this is an excellent performance. We wanted 30 minutes or less, and the pizza store is, giving a performance of average delivery time of 23.5 minutes. Everyone wants it, say online, it's a performance is great. But is it great? No, it is not great. That is what, Sigma would say. Six Sigma would tell us. You can see in the diagram, look at the variation. This is 30 minutes, less for 30 minutes. X shows the average. 23 minutes, which was the, the average of the deliveries, 200 deliveries. Average was 23. This is the, 30 minutes or less. The white portion still shows the persons who did not get within 30 minutes. The concept is, when we calculate the average, of course, the average is 23 minutes, which is less than the, the guaranteed performance 30 minutes. But this is the actual state. The white, the white portion, it shows the customers who got after 30 minutes. So this is the real story, that we are not getting good sigma performance from this Domino store. Of course, they are on an average basis, they may be doing well, but when we see at the broader view, there are a lot of customers who did not get their delivery within 30 or less than 30 minutes. So I would say managing by the average does not tell us the whole story. The statistical quality control, they depended on the average values. The average and the variation, we have to, minimize the variation. That is what we will call as improving the performance. We have not only to improve the average, we also have to improve the variation. And when we improve the variation, then only we can say that, yes, we have a good performance. So when we reduce the average, now you can see in the diagram, still we go by the same 30 minutes or so. Still we go by the 23 average. But, we improve. How? Now in this, we can see that the white portion, when we improve the sigma level, the variation gets reduced, and number of persons who got the delivery beyond 30 minutes has been considerably reduced. So performing on the same average level, the same targets 30 minutes or less, we have strictly reduced the number of persons who were unsatisfied with getting their delivery beyond 30 minutes. So this is what is the practically we can understand, improving the sigma levels often helps us to meet the customer requirements of maximum number of customers. So that is what we call as improving the performance, continuous performance, improving sigma levels, and gradually, when we still go higher and higher, the white portion may come to almost zero. That would be, achieving 6 sigma levels in the delivery of the pizza at the Domino's. So that is how we are gradually going up and up and improving the performance. So this is in general, when we have 1 sigma level, our performance is almost 31% good, 59% bad, and defects per million opportunities is almost 69%. When we are able to achieve 2 sigma, percentage almost is reversed. It is 69% good, 30%, 31% bad. And when we are working at 3 sigma level, this is a very steep jump, almost very steep jump. So when we achieve 3 sigma limit, percentage good percentage of the good items or selected items or within the limits, that jumps from 69 to almost 93.3%. So that means in 1 million, 10 lakh, 66,800 something, they are likely to be rejects or not selected. And from 3 sigma, when we are able to reach 4 sigma level, our percentage improves again considerably. It's almost 99.38, which to a layman, it looks almost 100%. And in 10 lakh 6,000 items may be getting rejected. So 5 sigma level, it's 99.97. Again, looks wonderfully well. Rejects are 233 out of 10 lakh. But our excellence, we cannot talk of excellence unless we reach 6 sigma. And 6 sigma means 99.9997. So that means out of 10 lakh, hardly 3 items are getting rejected. So that is, one when we say it's a world class performance when we reach 6 sigma. So when we talk of Six Sigma, there's very important term 1.5 Sigma shift. This is a very natural process. Whenever we are doing manufacturing, it's an inherent the phenomena that due to fatigue or due to say decreasing performance of the human factors, or you say even the machines, the quality the gradually very slowly comes down. This is the theoretical sigma limit, which we are, say for example, we have achieved this 6 sigma level. This is a mean in the center, and on both sides we are within the specification limits. We have achieved the 6 sigma. But when we look at this diagram, we would see that the manufacturing performance, in terms of manufacturing performance, there is always a shift in the mean with the passage of time. So this is the actual mean, which has shifted a little bit from the theoretical mean, though the process still is working in the specification limits. Now you can see it. The process is still in the limit. Actual mean is there. So on the right side, we have, the sigma levels, they are less than this. They're almost 4.5.
We have.
This is a natural process, what we call as 1.5 sigma shift. The process has shifted from 6 sigma to 4. So this is called theoretical 6 sigma minus shift. Shift in the mean is almost 1.5 sigma, and the process, theoretically it may appear to be working at 6 sigma, but actual it is working at 4.5 sigma. So this is a natural shift, 1.5 sigma shift, which is an inherent process, nobody can help it. So examples of 6 sigma, there seem to be very interesting. When the word works at 3 sigma level, and when the word works at 6 sigma level. In US, if there are 964 flights cancellations per day, when the US aviation industry is working at 3 sigma level, when it would work at 6 sigma level, it would be observed, instead of per day, out of 3 weeks, there will be only 1 US flight cancellation. This shows, this is just to emphasize the shift in the quality. 964 flights per day cancellation. It changes to 1 cancellation in 3 weeks. So you can just see it almost, out of 3,600 flight cancellations, it has come to only 1 flight cancellation in 3 weeks. Even for the police in the security, if a police makes 7 false arrests in 4 minutes, there will be less than 4 false arrests in 1 month. So what we are achieving in 4 minutes, that that would be spread over 4 months, full 1 month. So that is the shows the extreme improvement in the quality with when we the working goes up to the Six Sigma level. In medical America, uh, so it's very hypothetical. When it says 5,390 newborns are dropped due to some reason, if you know, in the medical America, the improvements are there, hardly one newborn will be dropped in 4 years. Similarly, it is not shown in this in terms of accidents in the transport sector. When it is, similarly, it drastically comes down. The number of accidents, today we have so many accidents. If we study the transport sector in terms of accidents on the roads, and we employ the Six Sigma strategy, drastically we can bring down the accidents. Say in 1 hour, around 48,000 international calls, they are disconnected accidentally. When we employ the Six Sigma quality level, it would take more than 2 years to see the same number of drops. These examples, they are just showing in a word in a word of 3 sigma, this is the quality level, and drastically, exponentially, there is a improvement in the quality when the word works at 6 sigma. Even if you take these examples as hypothetical, but they're nice enough to show the emphasis, they're nice enough to emphasize the beauty of sigma. So Six Sigma is basically based on 4 performance pillars. The first is a level of performance that reflects significantly reducing defects in the products. There is a significant reduction of defects. At Six Sigma, we have just 3.4 defects in 1 million. Second is Six Sigma, it's a statistical measurement of a process capability as well as a benchmark for the comparison. Unless and until we have a statistical measurement, how can we, everything has to be measured. Everything has to be in a tangible form. How do we manufacture quality, measure quality? We cannot say it's a very, say very rough way of saying good quality, bad quality. It has to be quantified. So we can say a level, Six Sigma level, 4 sigma level, 5 sigma level. So statistically, there has to be some measure and some quantity needs to be depicted. Then we have to, analyze various phases statistically and improve the process. We have to quantify the improvement. Yes, earlier we were doing at this level. Now we are doing at this level. Earlier we were saving 1 lakh rupees. Now we are saving 7 lakh rupees. So everything needs to be quantified. Unless we quantify it, we cannot justify the improvement. And the last is a commitment to customers to achieve the acceptable level of performance. So we have to commit to the customers. Yes, we are working within your specification limits, and we are also doing what we promised. So this is, again, the old concept of quality. पहले क्या होता था? The quality used to be defined as conformance to standards. Whatever the standards were set up, if we are within those standards, we used to say we have received the quality. And earlier क्या होता था? पहले quality was, the buzzword only for the manufacturing sector. In a plant, on the shop floor, people used to talk about quality. इतने डिफेक्ट्स हो गए हैं, इतने रिजेक्ट हैं, इतने ओवरवर्क हो गए, इतने अंडरवर्क हो गए. So that is what, the quality was mainly confined to the manufacturing floor. It was mainly, the duty of the supervisors, the workers, and the production managers. But now quality is not only, we talk of quality not only for the manufacturing sector, even for the packaging sector, even for the loading and unloading personnel, even for the supply chain management. The supply chain management is working at this level or this level. Even everything, right from the plant or right from the manufacturing stage to the stage when the product comes in the hands of the customers. It is handed over to the customers. Everywhere now we are talking of quality. We are talking of the concepts like after sale service. Even it has been sold, it has come to the customers. How the customers are satisfied, attracting the customers even after they have used a product. Every a Maruti, they would send us a message like happy anniversary, happy birthday, or they would remind us that your service is due, your first service is due, or even in a COVID period, they would remind us that you need to do like this or need to do like this. They would be sending us instructions to keep our vehicle in a good condition. All these things, they are not mandatory. They are just to attract your customers. They are a part of quality management. They are a part of after sales service. So what I mean to say is the quality standards, they are not only confined to the production area. Now they are beyond the production. They are even into the commercial areas now. Sales. How do we achieve good sales? After sales service, sales promotion. How to promote sales. This is a part of the quality management area. How to improve the quality of the sales. So even a bad product can be sold to the customers if it is the quality of sales or the sales process is very good. People are not no People are not worried even for the price. People are more worried for the quality. And once you have the brand value of, you have earned the brand value, you can just you can encash that brand name. You can even sell bad quality at a higher price. That is the quality. That is the beauty of the quality of brand. A good brand, even if doesn't work, we are not going to complain. We are happy to wear a Nike shoes because yes, the brand name is there. But even if it is not working beyond 2 years, we are not going to complain. So it is a very well defined process how to the maintain the brand quality, how to maintain, how to earn, or how to enrich your brand name. So this is all. Quality is not no longer it is confined to the manufacturing sector. So in Six Sigma, earlier we talked about the poor old concept. Now we are talking of the new concept. In the new concept, we talk of Six Sigma. Six Sigma, the quality not only encompasses the manufacturing sector, it even goes beyond it. It goes into the commercial area. It goes into the service sectors. Even it affects the service quality. So people are not worried only for the manufacturing quality. They are even worried for the delivery, quality of delivery, quality of packaging, quality of availability. A process is not available in the market, a product may lose customers. A customer may try another product. So quality now is everywhere. So under this new approach, we call quality, it is a state in which there is value enrichment. Now we are talking of the value enrichment. The value enrichment for the customer. कि customer को कितनी value दे रहे हैं, that is what the quality reflects. And the term value enrichment for the company means that company must produce highest quality products at the lowest possible cost. That is for the company point of view. And for the customers, the value enrichment means they have the right to purchase high quality products at the lowest cost. So the value enrichment for the customers and for the company, it is complement. The company would also strive to achieve value enrichment. The customers also want value enrichment. So this is again, a very good line. These 3 points are very good. If we go through these points, Value enrichment for the company and the customer is done by a measurement-based approach of Six Sigma. The Six Sigma would emphasize on the measuring how much the value enrichment is going to the customers, or how much value enrichment is the company availing itself. There are vast areas of business about which we do not know. Say a product is being launched in the market. We launch the product. Our duty doesn't stop there. Shouldn't we be worried about how it should be delivered? Is the delivery timely, or is the delivery comfortable? Is the customer getting product as and when he wants, the timely delivery? So there are vast areas of business which we still have to explore. We have not explored, and Six Sigma would help us to explore it. So there are vast areas of business about which we do not know. And when we do not know a process, we do not value it. हमें किसी process का पता ही नहीं है, तो हम उसकी value भी नहीं जानते. And when we do not value a process or a parameter, we do not measure it. So when we do not know it, we do not value it. And when we do not value it, we are not going to measure it. And when we do not measure a process or a characteristics, we cannot improve it. So Six Sigma will start from the reverse. They would improve the process so that it is measurable and it is valuable, and the customer should know that, yes, I am getting good quality. So Six Sigma, because of its inherent, emphasis on measurement, it has a very good impact on the cost of quality. As we go on implementing Six Sigma techniques, we gradually improve with Six Sigma, we would see that the cost of the quality is gradually decreasing. At 3 Sigma level, the cost of quality is high. As we go to the 4 Sigma level, the cost of quality is very low. At 6 Sigma level, it may be still very low. So, the cost, when cost is low, it gets compensated with whatever we are spending to improve the Sigma level. So we cannot say that improving Six Sigma level is a costly process, because if we are spending something on improving the Sigma levels, definitely we are also getting a good, amount of price fallback from the fall in the quality costs. There are a lot of quality costs which are, openly visible, and there are so many quality costs which are hidden. So we can categorize our quality costs in two categories: hidden and open, or hidden or visible. And normally we have seen that quality costs, additional costs, they are around 20 to 25% of the sales. And when we work on Sigma level, they can be brought around 5%. So if we see that visible cost, दोनों कॉस्ट क्या है? क्वालिटी की कॉस्ट है. क्वालिटी विजिबल कॉस्ट आर स्क्रैप, reworks, and warranty costs. There is a difference between scrap and rework. Rework is normally oversized items. We can work on them and bring to the actual size. And scrap normally is the undersized item or the defective items which cannot be reworked, and normally they are sold as scrap. So scrap, rework, warranty costs, they are visible costs. And there are so many costs which are hidden, which are normally not visible, like conversion efficiency of the materials. Many times the material, may not be good, or the process may not be good. The material may not be being converted 100%. There may be a lot of waste in the material, which has to be, identified. Inadequate resource utilization. Machines may be, the second point, inadequate resource utilization. There may be many machines which are lying idle, and there may be some machines which are short under there, for which we are feeling shortage. So we have to, do a lot of line balancing. That is, that would improve the resource utilization. We may not be having um, a good or the quality labor in one area. We may be having excess labor in another area. That would again amount to poor human resource utilization. Then excessive use of material, a lot of wastage is being there. Cost of redesign, again, there are a lot of rejects. The customer specifications are not being met, or the workability is poor. Then again, you have to redesign. Redesign means then re-inspection has to be done. Customer problems आपके पास कैसे आ रही हैं? How do we resolve them? And if we are not giving good products, we lose so many customers, their goodwill. This again is a very serious, cost. High inventory. That is why we are talking in terms of, um, pull system or the just-in-time system. So all these costs, hidden costs, we normally don't talk of. We normally don't observe. We don't put emphasis on. And when we do work with the Six Sigma technique, the Six Sigma, they would hit all these hidden costs. When we go to the third step of Six Sigma, that is analyze. And during the analysis phase, we hit upon these costs. So we hit upon these quality costs. And when we hit upon these, we remove many of these costs, and that would considerably bring down the quality cost. And, overall cost of the product comes down and the quality improves exponentially. And that is what we call, we are going in for higher and higher sigma levels. This is the cost of quality corresponding to sigma level. When we just have one sigma quality, there's a lot of defects, lot of, parts per million, they are being rejected. The quality of the cost is normally more than 40%. Similarly, at 2 sigma, the cost of the quality is 30 to 40%. And such a stage, we call it as non-competitive. We normally are going to fall in a lot of losses for the company. This is actually not competing with the customers or competitors, sorry. So 2 sigma or 1 sigma, the cost, around 40 or 40%, more than 40%. Obviously, we can imagine that when the cost of quality is so high, the cost of the product is going to be very high. At 3 sigma or 4 sigma level, at which normally the Indian industries are working, the cost is around 20 to 30%. And if we still go for 4 sigma, it may be around 20%. So this is an industry average, tolerably. This is just tolerable, but absolutely not expected. So when we aim for 5 sigma or 6 sigma levels, the quality of the cost, it comes down to around 10 to 15%. And from more than 40%, it is coming to less than 10% in the top level. So obviously, 30% reduction in the quality cost and much more improved quality, that is what puts us at the world-class manufacturing. And that is what, the topic of your faculty development program, the theme of your faculty development program, manufacturing excellence. So this is, the world-class manufacturing or world-class level corresponds to your manufacturing excellence. Six Sigma places a clear focus on the bottom line. Bottom line means it focuses on whatever, can be improved at the ground level. And at the ground level, most of the times it is hidden. The hidden quality costs, they are mostly existing in the bottom line. The resources are not being used. You can see in there, the resources are not being used. The materials are getting wastage. There's a lot of re-inspection. A lot of customer problems are not being resolved. high inventory. So we can observe that all these hidden costs, they are lying at the ground level. And the Six Sigma strategy, it hits the bottom line. And no Six Sigma project is approved unless the bottom line or the success factors are clearly spelled. You know, when we work on a Six Sigma strategy, it's a project-based approach. It's a project type of project which normally takes 3 to 6 months, and at the end of the project, we would actually quantify the results which we have achieved. So at the strategic level, the goal of the Six Sigma is to align an organization to its marketplace and deliver the real improvements to its customers. And the improvements, they should be really interpreted in terms of rupees. Yes, we have saved this much, we have saved this much money. And at the operational level, the goal of the Six Sigma is you know that we have achieved this much process capability. We have moved from 3 sigma to 5 sigma. We have moved from 2.4 sigma to 6.2.4 to even 2.6 sigma. So that is, improving the capability that would be operational. So Six Sigma, just summing up what we have studied till now, it covers up the process improvement. It covers up the product and the service improvement. Both of these, they lead to the better customer satisfaction, better design methodology, and supplier improvement. And all these, when together, suppliers, they give inputs, the business process is getting improved, the process outputs are there, and the critical customer requirements, the feedback from the customers, and that can be interpreted in terms of the defects, and the variation can be studied, and all these processes can be improved by Six Sigma. So we need strong leadership, we need training, we need customer focus, we need project teams which need to work on Six Sigma project, and a culture change in the whole organization that would help us to achieve Six Sigma or Sigma culture in an organization. So strong leadership from top to bottom. Then training, we would be studying, we have champions, black belts, green belts, and all those persons which deal with the Six Sigma. Then we have customer focus, then project teams and culture change. Then this is, process elements. In Six Sigma process, variation is analyzed. And, once we analyze the variation, we have a disciplined approach, step-by-step approach. Then almost all the results, we never study in intangible form, we quantify them. We always put our measures in quantifiable form, and statistically we analyze them, and the process gets improved. We would see with the different steps. So this is how this shows the journey of the Six Sigma, how they evolved over the time. So we can see that Six Sigma process can be said to be having roots to 18th century, when Gauss gave us the normal curve, the Walter gave us the Chevert process, the control charts. They form the basis, the normal curve and the control charts. They help us to, measure the quality levels where we are working. Then there were some in 1736 French mathematicians. He worked on normal curve. Then US mathematician, he worked on critical analysis. Then they worked on different cause and effect diagram. we study normally in the manufacturing mechanical engineering. Then in the 19th century, Alexei Osborne, he gave rules, he adopted brainstorming. And brainstorming is a very important part of Six Sigma process. And then uh, Noriko, he gave types of different types of quality models. Then Bill Smith, he was an engineer and he was the one, who conceptualized the idea of Six Sigma at Motorola. And 1994, the Motorola adopted and launched this Six Sigma. So these are the world-class companies who have been working on Six Sigma since long, and there's a lot of competition. Which level of Six Sigma you are working? Many of the companies, uh, when they outsource, they put a condition even to the outsource companies that you should have a Six Sigma working level of this much Six Sigma. So it has become a very important part of your working culture. So General Electric, Ford, Honeywell, Johnson and Johnson, John Deere, then Motorola, Black and Decker, Sony, all these, Caterpillar, they have adopted. GM, they have adopted these. Some of these are manufacturing, many of these are service industries. They've all worked on Six Sigma. Then financial services, uh, Six Sigma, it is finding application in the transport sector, waste management sector. It is finding application in the service with other sectors like education sector, even in the financial or the banking system. And these are some of the, you know, uh, companies where Six Sigma has fared well and adopted by the companies. So in the Indian context, when we study, there are a lot of challenges for the Indian companies. It is high time that Indian companies also start implementing Six Sigma. Normally, when we observe our manufacturing levels, we can just interpret those levels in terms of Six Sigma, and we can say that we are working at an average of Three Sigma levels. So to be globally competitive, we have a lot to do in Indian companies. We have to bring a lot breakthrough improvements, not simple improvements, not gradual improvements. So we have to break through or, re-engineer the systems to become globally competitive. So there are, in Six Sigma, there are five fundamental steps. There are five fundamental steps of Six Sigma. These are, the first is define. Second is measure, analyze, improve, and control. And in short, we call it as DMAIC. Define, measure, analyze, improve, and control. We also say Six Sigma is, a project-based strategy. It's a sort of project type of work. There can be a team or there can be an important phase when we are just start with defining the problem. Then we come into the second stage, measure. Then we come to the third stage, analyze. Then we come to the improve. And last is then we control the process. So it's a, step by step approach, or we can call it as a project. We take it and end of the last project. End of the project is, the end of the stage, that is control, where have we can quantify the results. And these stages, basically, first stage, it should be, when we make a roadmap, problem has to be identified. You have to identify. Even a layman would say, what is the problem? Why this problem? How long you have been facing this problem? So this is, these are the steps of identification. Even if you go to a doctor, a patient goes to a doctor, the first question the doctor would try to identify: what is the disease? Since when you have been facing it? What is the problem? Since when? Since long? How long you have been facing this problem? Why this problem? What is environment around you? You know, a doctor would try to define the problem, or he would try to identify. Similarly, in a manufacturing environment or a service industry, we have to identify the problem and what are the key business issues. That is what we call as define phase. Then the second is the measure and the analyze, or the characterization. Say a doctor defines that you are having a fever. Okay. The second is, now who would try to measure how much fever is there. He would put a thermometer. Maybe you are having 103 or 104 degrees. So he has measured it. Then he needs to analyze. Maybe he advises you to go for a blood test. Why this temperature? It can be a viral infection, or it can be due to some other reason, or it can be a dengue fever, or it can be another fever, there are so many types of. So he would try to analyze it. This is called analysis. This is also a characterization. So similarly, in an industry is facing a problem. If a problem could be lot of scrap is there. A problem could be very high manufacturing cost. A problem could be, you know, customers are not satisfied. A problem could be, you know, very high delivery time. A problem could be, say, poor workability. Any problem. So you have to identify, then you have to measure and analyze. That is characterization. So that means objective is to understand the performance level. कि हमारी क्या performance level कितना है आजकल. And then we try to compare the current performance level to the previous performance levels. And that would, you know, help us to analyze कि पहले क्या था और अब क्या है, and why this. Then improve or optimize. Doctor भी ऐसे ही करता है. Once he gets the blood test report, then he would tell us to go in for some medicines. वो हमें कुछ medicine देगा, and due to those medicines, कुछ maybe some enzymes get improved, or some, you know, factors would in the blood the blood culture, जो हमारी whatever the shortcomings are there, they would get improved. So he would advise us to have some medicines, and that would help us to improve. So that is improving, achieving improvement, optimizing. So similarly in the industry, defects have been defined, the problem has been defined, the problem has been measured, and reasons of the problem have been identified and analyzed. Now we improve one by one those problems, or those reasons, they are removed and improved. That is called optimization. And the last is, you know, control. डॉक्टर हमें दवाई देता है, दवाई देने के बाद हमें precautions बताता है that you don't have to take lot of water, you have to keep yourself hydrated, you don't have to go in the sun, you have to take lot of rest. So that would help us to sustain your body and improve the health. So similarly, your defects have been defined, improved, measured and improved. Then how to sustain it for a long time. Then some controlling parameters are, you know, institutionalized. We integrate Six Sigma in day-to-day functioning, and that is, you know, the objective, and we are well good into the nice process. So as I was talking about the 5 steps of Six Sigma. So this is define, measure, analyze, and improve. So define, objective is define the opportunity, define the problem. Here opportunity means problem, and Six Sigma people see problem as an opportunity to improve. So define the problem, what is the shortcoming. And there are a number of tools have been suggested for this stage. And please see that all the tools are not applicable everywhere. The selection of tool is itself, a very important factor, that which tool would be applicable to which problem. But these are just a few of the tools. There are still there's a long list of tools for all the stages. For example, for define the cost of poor quality, COPQ, we have been using it many times. Voice of the customers, or the voice of, we also have call it voice of stakeholders, or VOC. Project charter, it's a project scheduler. Then as is the process map, we also have, value stream mapping, then primary metric. These are some of the tools which we can use in the define phase. Then similarly in the measure phase, when we are measuring the process, where we are measuring the performance, then CTQs are there, critical to quality. Sampling, sample plans are there, capability analysis, even a softwares are there which would help us to measure it. Then failure mode and effect analysis. Then the third is the analyze stage. Analyze stage में हम क्या करते हैं? Now we have measured the performance. Analyze stage is we try to make a long list of causes of the problem. What are the root causes which are, responsible for the problem? We make a list of, 50 causes, for example. Out of those 50 causes, then what we do it, we categorize those causes. Out of 50, there may be 4 or 5 causes which are very critical. So we call them as critical to performance, CTQs. There may be some causes which are important, and there may be causes which are not very important, and there may be a big number of maybe there which are not very trivial nature, which are not important. So causes can be critical, very important, not at all important. So causes which are not at all important, you need not waste time on this. Anyway, they are not affecting much. So we normally emphasize on very important and critical factors. And there are tools to analyze those, like histograms, box plots, multivariate charts, hypothesis. Hypothesis can be set up, regression analysis. Then there are a lot of statistical tests are there, which help us to, analyze. And statistical analysis normally is a major portion of this portion. Then improve, because you have analyzed, आपको पता चल जाता है कि कौन-कौन से critical हैं. Then one by one we hit upon those critical causes, CTQs, critical to qualities, and one by one we hit every individual critical cause and try to improve and remove that cause. And that is, the objective of improve phase. And tools can be solution selection matrix, to be process maps, and so on. And once we have improved, we have removed the causes, we have removed the critical, shortcomings, then that is not the end. Maybe after we leave, the process may, there's a very natural phenomenon, that resistance to change. Even a worker would resist change. He will not adopt the new suggested measures. So how to sustain that change? How to institutionalize? How to make it as a part of culture? So that is, a very important phase, controlling the process to sustain the gains. Whatever gains which we have suggested, they also should be sustained. And, many tools are there. Contingency plans are there, action plans are there, control charts. These are all, tools are there which help us do this process. Then define. What is define phase? As I talked earlier, what is the problem? Problem is, say, a output in the math equation. what is the cost of this problem? What is the cost of this problem means, say, the cost of this problem is a few thousand rupees, then we need not touch the problem. Why to waste time on this? If the problem, the company shows that due to this problem, the company is, losing 100, lakhs or say 50 lakhs per annum. This is a critical problem. This must be resolved. So what is the cost? What is the problem? What is the cost of the problem? Who are the stakeholders? Who are the affected persons? Who are making decisions in the problem because of this problem, affected by this? And then what expectations are there? What resources are being aligned? All these processes, they are part of this defined. This is just a very good example how the process works. So how does our existing process works? So we make an outline कि कैसे हम process work कर रहा है. Sometimes we even call it as value stream mapping of the existing process. Then within the process, within the defined phase, we clearly make a list of customer requirements. What are the customer expectations? What motivates the customers? So customer mapping could be there. Voice of the customer, उनके key issues क्या हैं? Out of those key issues, what issues are directly or critically affecting the quality? They can be filtered out. So this is, various types of tools are there, which are, can be used. So which can be used to make. Then after defining what is the problem, what is the cost of the problem, who are the affected persons, how long the problem has been there, then we make the baselines and then we measure the process. We collect the data of previous few years, we collect the current data, we compare the data, and we can make a list of the defects or the problems, and we can make, descriptive statistical analysis could be done with the help of a software. So this shows the Pareto chart, Pareto diagrams. We are very common. Every mechanical engineer would know what is a Pareto diagram. So this, say, for example, this Pareto diagram shows that the first is these are the defects which are majorly affecting almost, it shows that almost around 80% responsibility lies with these defects. The second category is, they're not so much important, and the last is the trivial defects. So we measure various types of defects, or the reasons are there in the second phase. Then where does the process fail and why? This again is to be measured in the second stage. Why the process is measured? What are the failure modes and the effect analysis? What is the effect? What is the failure mode? So all these things are recorded. Then once we have the measurements, we analyze. And as I was talking, out of a long list of root causes, we filter out what are the key root causes. We have to, make a list of key root causes. What are the critical factors? Because we are not here to say there are 100 factors. We are not here to hit all the 100 factors. We can, this is a 80-20 rule. 80% of the factors are just causing 20% of the problem. They are trivial factors. We need not hit them. 20% of the factors, they are causing 80% of the problem. They are the critical factors or the important factors. They need to be hit immediately. So we analyze these factors, and once we have analyzed these factors, we try to improve each and every critical factor, that is analyzed. It is hit upon. We try to improve it, or what factors, what improvement. A factor is dealing with a machine, a problem in the machine, we can replace the machine, or we can replace a part of the machine, or the rejects are due to some, say, some pressing process, we can change that process. Or so what I mean to say is individually we have to hit every problem and remove it. And this is the stage where we take a lot of help from the softwares. We take a lot of help from techniques like, um, neural networks and all these. Maybe we would try to identify what type of technique or what type of tool would help us to hit the cause and remove it. That is, improving the problem. Then out of many improvement solutions are there, and out of many improvement solutions, there may be a few, but we have to, then feasibility analysis has to be done. What is the best solution? What solution gives us the best gains? So that solution is finally selected. So out of, say, 5 solutions, a feasibility analysis can be done in terms of availability of resources, or in terms of availability of uh, manpower, or in terms of, the gains to be achieved. And finally, the best solution is selected and improved. And then how to hold the gains, how to sustain the process, that comes in the control phase. We have to say, for example, we have to do a lot of training for the workers. That is a part of the control phase. We have to train the workers on the new machine. We have to train the worker on new process. Say there is some, some sales, we have suggested some improve in the sales procedure. So the salesman has to be trained on that sales procedure. So we have to train them, or just to give them again reminders, we can even put billboards in the shop floor itself. Those billboards can highlight the new techniques or the new improvements, so that whenever a worker looks up, he is reminded. So how to improve, sustain that process, different measures can be adopted to control. So similarly for the design, it's almost same. We define a process, we measure it, we analyze it, and instead of improving, we say we develop a new design, and instead of controlling, we say we verify the new design which has been suggested. Now we talk of Six Sigma players. Every industry, as I was talking, there is a team for the Six Sigma. It's a project-based approach. So on the top, it has to be led by the CEO, the Chief Executive Officer of the company. And normally he's called the champion. So the boss of the company or the boss of the project is normally the champion of the Six Sigma project program. So under the CEO or the champion, or the deputy CEO can be the champion. So under him, different leaders have to take charge of implementing the programs. The champion must have complete hands-on experience with the sound knowledge of the advanced statistical. So whoever is the champion of the Six Sigma team, he is expected to be knowledgeable on various tools. So he must have had a good amount of training so that he can be a good leader. So what is the role of the champion? A champion needs to promote awareness and execution of the Six Sigma within the business, within lines of business or the function. There are always, the company limits. So a champion has to be within those limits and work. He must identify potential Six Sigma projects for his, the persons who are working under him, for example, black belts and green belts. So because since he has to lead his subordinates, he must be aware of the different, what work has to be handed over to which black belt and which green belt. He also needs to identify select and support black belt and green belt candidates, because all the black belts and the green belts, they would be looking towards, they would look towards their champion or their leader to guide them. So he must have a good training, and he should be well aware of the processes. So success of Six Sigma to a very large extent depends on the selection of the right people. The champion, or what we call as CEO, he should ensure that right people are selected for the right job. They must have a good mental aptitude. They must have good qualification, and immediate team working under the CEO. They are called black belts. Even the black belts, we have black belts. We have even in the judo, karate. So black belts, who are black belts, they work under the chief executive officer or the champion within that project team. The black belts would use Six Sigma methodologies and the advanced tools. They are dedicated full time. They are not working on the manufacturing plant floor or the other quality departments. They are a full time project persons. 100% they are devoted to Six Sigma implementation for, say, whatever the time period the project is there. They would serve as Six Sigma leaders to their further subordinates who are green belts, and each green belt or each black belt, they need to have almost 5 weeks of training so that they can lead their subordinates. Then why do we have this? This is just a comparison between black belts in karate and black belts in Six Sigma. In karate is a game where your mind has to be focused. A lot of focus is needed. A karate player needs to have a lot of power, lot of speed, lot of focus, lot of decisiveness. Similarly, in a Six Sigma project, the black belts are the people who are working under the CEO. They need to take quick decisions. They need to have a lot of energy, lot of power. So that is why when we compare the two, their roles are almost similar. We call them as black belts in the Six Sigma black belts. Then under black belts, we have green belts. Green belts, they use Six Sigma methodology and the basic tools. They further lead smaller projects within the business unit. They must have basic Six Sigma concepts. They must be knowing tools which are being used in the Six Sigma project. And they also need to have around a 2 weeks training on the Six Sigma project, 8 to 10 days of training. So what we conclude is that this is the golden chain of Six Sigma. First, we hit upon the error reduction. And when we hit upon error reduction, we get a lot of improvement, and lot of improvement yields a lot of customer satisfaction, and customer satisfaction is there, lot of sales and lot of income. So that is what is the ultimate, golden chain, what Six Sigma leads us. There are a lot of Six Sigma softwares are available in the market for all these different steps. They can be, contacted. They can be used. These are the softwares which are basically being used even in the initial stages, or the research scholars or the industry people. They are all available, and they have their own applications. But again, I would say each software has its own specific application. Every software is not applicable at every problem. We have said so many good things about Six Sigma, there are some critics who say that there are some drawbacks in the Six Sigma. They say Six Sigma, there is some lack of originality. Six Sigma is basically, putting quality control tools in a different manner. I agree. Six Sigma is using the available quality control tools, but it has, what it has, Sigma has done, it has systematically put them in steps. It has systematically, you know, put a diagnostic strategy. Say, first you define, then you measure, then you analyze, you improve and control. So this is, a systematically diagnosing a problem that, yields better results. Then role of consultants. Consultants have a bigger role as compared to, the shop floor people. This is absolutely not correct. When during the third phase, that is, fourth phase, that is improvement phase, we do a lot of brainstorming, and brainstorming involves the shop floor engineers, the workers, the supervisors, the foremen, and their ideas, their, what their feedback is of great importance in the improvement phase. So there is a lot of negative effects, over reliance on statistical tools. Of course, statistical tools help us to quantify. Then creativity in the research environment, we are using the same tools or the existing, but we have on every company has got its own limitations. R&D, R&D infrastructure is not very strong in our Indian companies. R&D spending is not very high. So we have our own limits. So we don't go in for very original research. We do within our own means. Then systematic documentation may not be there. So these are some of the things which the critics have been saying about Six Sigma. The history of the Six Sigma, why Six Sigma was very popular. When Motorola used it around beginning of this century, they said that we have achieved 200 times reduction and a saving of around $15 billion. General Electric, similarly, they reported a saving of $2 billion in 1999 with a 62% reduction. Then Honeywell, Ford, Caterpillar, Our Lady of Elm Center, every industry, they reported around the beginning of this century. And so, no, these gains, these are the six, we call them as six sister concerns who were, responsible for popularization of Six Sigma. Because these are the companies which show to the world that Six Sigma has a lot to offer. It has got a lot of future. And all these companies, they are not very many of them, like Our Lady of Elm Center, it's a healthcare industry. So it also shows that not only the manufacturing sector, even the service sector has a lot to gain from this. Even in Indian context, this is our personal work. The Six Sigma project was undertaken by us at Federal Mughal Casting Industry in Patiala. And these were some of the these basic, achievements or the results of our Six Sigma project. The existing high scrap was a major problem which was identified in the define phase, and reasons for this war response. Basic, scrap was existing because of defects like shrinkage, bottom thickness variation, blowholes, and all this. And the parameters responsible were identified as a poor in-gate design, dimensional inaccuracy of the machine, die temperature. They were, identified as main reasons for the above defects in the foundry industry. Then these were the instruments which were not being used properly. This comes under the gauge study. Then in the analysis phase, there were many processes were identified which were leading to a lot of defect, scrap, but 10 critical reasons suspected SSVs suspected sources of variations were identified, and these have been written in there. So we were able to filter out 10 SSVs finally, and they were, each SSV was finally hit upon, improved, and they were optimized, and a significant reduction of 7% in scrap was, we were able to achieve it. And overall scrap of the foundry was monitored by charts, and it was controlled up to 10.43%. So after this Six Sigma case study, BT variation was monitored, and these are some of the results. And it shows that, even in terms of financial gains, we can see that earlier this foundry industry was working at, when calculated, the working level was 3.4 sigma, 3 sigma level. And after improving, there was a minor improvement of, it was raised by 0.24. That means improved sigma level was 3.57. But just 0.24% improvement in the sigma level, it brought a saving of around 31 lakhs per annum. So just you can imagine, if the company, under professional guidance, it reaches up to 5 sigma or 4 sigma level, how there will be lot of financial gains for the company. Similarly, the study was repeated at Rajiv Gandhi Thermal Power Plant SR. And this is before Six Sigma, our Six Sigma project capacity waste was almost 50%. It was brought down to 42%. Process capability was 0.42%. It was improved to 0.62%. Sigma level of the very poor performance was there of the 0.25, but still it was managed that now the thermal power plant started working at 0.9, and and the waste reduction got improved by 8%. So these are some of the basic 2 case study results which show that a lot of improvement can be done with Six Sigma. So with this, I think I should test everyone's patience. You have heard almost for 1 hour 50 minutes. So this was just, I wanted to convey that this is what we can learn by using Six Sigma. And any question, any doubt to anyone?
Thank you, sir. Dear participants, if you have any questions for sir, kindly raise them, or you can also type them in the chat box.
Hello, sir. Good morning.
Good morning, Jay.
Hello, sir. First of all, thank you for such an insightful session. Sir, my question is that like Six Sigma has emerged both as a philosophy as well as a problem-solving tool. So how do you think, when we are other areas which are coming up right now is big data and design thinking. So how do you think that all these concepts can confluence to, and how we can tap their synergy to make them more useful and relevant in today's world?
Can you repeat the last part of how can we improve what?
Sir, how can we confluence all the concepts in order to come up with something and tap on the synergy part so that these concepts become more viable and more useful?
Can you name these concepts? Which concepts you are talking about?
Sir, Six Sigma, design thinking, and big data.
Six Sigma and design thinking and
big data analytics.
Okay.
Yes.
So I would just say, I would take my example. When we worked in the casting industry, Federal Mogul at Patiala, Um, when we identified 10 major variation causes or the reasons for variations, so there were about 4 reasons. They were primarily responsible for a lot of wastage. They were related to, basic machine design. There was a pressing machine, press. There was a hydraulic press, and that, hydraulic press. The we When we improved the setup time for that hydraulic press, and we introduced one pin in that hydraulic press was able to, eject immediately. So almost 6 to 7% scrap was because of that. So what I mean to say is, because of this Six Sigma strategy, the design of the machine we were able to identify, which otherwise could not have been, visible to even the workers. So this is how the Six Sigma analysis, or when we try to improve the process or the machines in the improvement phase, design thinking is there. And there is very important phenomena, participative design. And what is this participative design? When not only one person, a lot of persons participate collectively, and that leads to an improvement in the design, that is participative design. So when that machine was not working, about all 15 workers who were working in that machine, and 2 supervisors and 1 foreman, they were all involved. There was a 4-hour brainstorming session for all these 16 people. There were about 15 or 16 suggestions by these people. And finally, we were able to work on 5. Idea of the machine was not ours. Absolutely, the project team So together they were all able to participate in the process. And today, there is a billboard, and that the improvement, this improvement was due to the efforts of this, and this person, and they have been awarded this and this. So what I mean to say is, it's a collective approach. It's a participative approach. So we cannot segregate this, the design. By one, and finally, you are able to improve that 5. So what I mean to say is, Six Sigma is a philosophy. It's no longer a tool. It's a philosophy. You can implement it everywhere. Only thing is, you have to analyze all your problems step by step. You are able to define it properly. You are able to measure it. You are able to, analyze. I think, uh, I have a question. Do you have any case study on improving engineering college quality? One of MTech students at NIT Kurukshetra, he has done how to improve passing rate. He was working, he had done BTech at one of the private colleges. So I have that case study. So he has suggested a lot of measures how to improve passing rate of students. Yes, there is one in education sector. But I have a few ideas. There are a lot of accidents on the national highway. So you can select any national highway, many persons who are doing MTech or PhD. You select a particular highway, and you observe that there are a lot of highway accidents on this. So you can definitely select it as defined as high number of accidents. then you can measure it, and you can find out the reasons, why the reasons. You can club this problem with, one of your civil engineers, transport engineers. That would be so what I mean to say is, this is a very versatile philosophy, versatile technique. You can implement it anywhere.
Sir, there are a few questions in the chat box. You can type them. Hello.
Hello.
Yes, sir. There are a few questions in the chat box. I'll read it out to you, sir.
Okay, okay, please.
One of the participants is asking, do you have any case studies on improving engineering college quality?
I have a
Perhaps
one MTech thesis on this. I can share it.
Okay, sir. And there's another question asking for any examples of world-class competitive levels for Six Sigma. Perhaps any companies might be the question that you be being asked here. Any companies, or I think of world-class competitive levels?
ICCI Bank, they are working on Six Sigma, but definitely they are not world class, but they are able to reach, around 4 Sigma. So question is not which company is Six Sigma. The question is which are the areas where you can implement Six Sigma. And Six Sigma today is, has overtaken almost every area, whether it is waste management, whether it is construction industry or the transport industry or the hospitality structure or even the security. So everywhere. So I think I may not have a list of companies in the financial sector or the hospital sector, but the Reddy's lab in India, they have been able to achieve 5 Sigma level. So I think if you Google it out, you will get a lot of information on this.
Okay. I think any other participants with any questions? If not, we would be winding. So another question has come. Sir, how the quality cost come down if we want to achieve Six Sigma? Because in improving Sigma level, we need to install costly precision machinery, skilled labor, expensive inspection tools.
Yes.
So
Yes.
he's asking, how can the quality cost come
So
down?
on one side, we are investing a lot of money. So on improving, say, some machines or installing some machines, definitely I would agree that to achieve a better level, there is a lot of investment. But on the other side, say, for example, if we are able to move from 3 Sigma to 4 Sigma level because of this investment, as I was, if you refer to the chart, the quality DPMO levels, when we improve, when we shift from 3 to 4 Sigma level, we would observe that we are almost changing, we are almost shifting, saving lot of scrap or lot of defects per million. If you refer to the table, I don't have the table now. It is almost more than 30,000 per million. So the cost would get definitely compensated here when the scrap or the waste or the rejects, they are exponentially getting rejected or getting reduced. So that high investment which you have done to improve, that would definitely come down. And with the passage of time, as you proceed with more and more manufacturing, it is the law of the economics that you would start having a lot of saving. And we have also studied here that there is a lot of saving in the quality of the cost of quality. So that considerably comes down. And that reduction in the cost of quality would compensate whatever you have invested. So that is why we say, as we go for the better, more and more Sigma level, we also have a fall in the quality cost, and that would compensate each other.
Thank you, sir. So we'll be winding up this session. So thank you, Khanduja sir, for your precious time and the session. We are really grateful for your presence over here, sir, with your esteemed experience.
So my
And
thanks to all also for being wonderful audience. Thank you so much.
thank you, sir. Thank you so much. The participants to kindly tune in for the next session at 11:30 a.m., which will be followed by the final session and then the feedback and evaluation process. Thank you, sir. Thank you all, everyone.
Thank you.